Hi, I would like to go through the notes for pages 43 to 45. We are approximating square roots, so that is also the goal. I can approximate square roots. Approximate is just a big word for like rounding, coming up with an estimation based on the number that they give you. So we know that perfect squares are numbers whose square roots are rational numbers. So you want to get that. And square roots are going to be rational numbers. And then the perfect squares will always be whole numbers. And so let's look at some of the examples. Let's look at some of the examples to see which ones are perfect squares. Those are going to be the ones where you can say what times itself gives you the number that's in here. So like what times itself gives you 100. That answer is 10 or negative 10 because a negative times a negative is a positive. And so this would be a perfect square because 10 is a whole number. What times itself gives you 1? That's 1. So the square root of 1 is 1. What times itself gives you 12? Let's see, 3 times 3 is 9, 4 times 4 is 16. So this is not going to be considered a perfect square. Square root of 16, however, 4 times 4 gives you 16. 20, 4 times 4 is 16, 5 times 5 is 25. So that's not a perfect square. 50, 7 times 7 is 49. And then 8 times 8 is 64. So that's not going to be one. And then here, 64, 8 times 8 is 64. So it is a perfect square. So you're going to want to use square root of 100, square root of 1, square root of 16, and square root of 64. Sorry about the bell. And then for non-perfect squares, they are always going to be an irrational number. With the square root of while the square root of a non-perfect square is irrational, we can use our knowledge of perfect squares to estimate their value, and that's going to be the approximate. So, yeah. And so really the ones that we had up here, these would all be considered irrational numbers. So we know this one's not irrational, and this one's not irrational. This one's not irrational, and neither is that one. So we'll just delete the ones that are not rational, we'll delete the ones that are rational because they're perfect squares that we explained above, and then we'll keep the ones that will have the irrational. So now looking at page 44, we want to estimate the value of the square root of 50. So what you're going to do is you want to go between, like think of the perfect square before and after it. So the square root of 49, we know that that is 7. And then we know the square root of 64 is 8. So we know that the square root of 50 would have to be between 7 and 8 because 50 is between 49 and 64. 50 is 1 away from 49. It's 14 away from 64, so you can just subtract to get those answers. And so since 50 is closer to 49, the square root of 50 will be closer to 7 than 8. And so it should be a little more than 7. A good decimal estimate, since it's only 1 away, maybe 7.1. If it's about halfway between the two, you'd want to use 7.5. If these numbers right here, like if these are closer to being the same amount apart, that would be 7.5. Sorry. And then, so which of these following square roots is best represented by point A? So you can click on the yellow dot. Notice, so if we were thinking of square root, like this would be the square root of 9. This would be the square root of 16. So since A is pretty close to 4, means our answer is going to need to be pretty close to the square root of 16. And so then you'll be able to see that your answer should be C. So then now I want you to do page 45 on your own. Think about the square root of 22. It's going to be between what two whole numbers? It may help to like list the perfect squares. 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16. Continue counting them down until you get to the two, the one that's before 22 and the one that's after 22. And then that will help you come up with that. And then what would be the best estimate for the square root of 198? So you work on that and we are going to check it tomorrow.